Say you're trying to implement a compiler from WebAssembly to native machine code, maybe in a context where you're using WebAssembly's security guarantees for software-enforced isolation between untrusted user code. In this particular instance, we're loading from an address calculated by a local variable shifted left by 3. To lower this, we'd first need to zero extend to match the target's 64-bit address space. You might then have the idea to lower this left shift into an addressing mode that instead multiplies by a small power of 2. You could then generalize this, looking for similar patterns on small left shifts. In doing so, though, you'd inadvertently have introduced a critical security bug that allows malicious WebAssembly modules to read and write outside of their sandbox. While this real CVE was discovered independently by an expert engineer, our tool, named Crocus, aims to prevent these sort of bugs. On the same CVE, our tool produces the following counterexample, which demonstrates exactly what went wrong. The code was supposed to take a 32-bit value, left shift, and then zero extend, but the produced machine code instead performs those two operations simultaneously, allowing an attacker an extra 3 bits of address space with which to escape the sandbox. To reason about these rules, our tool needs to cross the semantic gap between the compiler's IR, the ISA, and the fact that the compiler supports arbitrary helpers. To learn more about how we do this, please see our paper and the corresponding talk. Thank you.